Hello everyone. In today's video, we will learn how to perform protein-ligand docking using Boltz-2, which is one of the latest AI-based docking interaction prediction tools. And before jumping into the practical workflow, let's briefly understand protein-ligand docking. And Protein-ligand docking is a computational technique which is used to predict how a small molecule, such as a ligand, binds to a target, which is basically a protein. And the main objectives of docking is basically predicting the binding pose and also identifying key interacting residues or estimating binding affinity. And docking is basically two types. One is site-specific docking, and other is blind docking. So in the blind docking, we basically do that. We basically select the whole protein for the binding with the ligand, and in the site-specific docking, we basically select the specific residue, which is basically a active site, and so that the ligand only bind with the active site, not with the whole protein. So this is basically main difference between blind docking and site-specific docking. And now let's go into the main part of this video. Just go to Google Chrome and search for Boltz-2. And after this, go to this link, NVIDIA, and also go to this link, Termarine Bio. Okay, just accept all. Okay. So now you can see that there is a protein sequence uploaded, or there is a ligand chain. For this part, we can only use CCD strings. So just ignore everything and click on the reset. Okay. So let's click on this reset, and now we have to add the protein and the ligand option. Okay. So here in this option, you can see that the add entities to fold. So this protein is selected already. So just click on the new, and here it is saying that enter the sequence. So let's take a sequence from Uniprot. Let's go to Uniprot, and let's just search for a protein. Go into this and then sequence, and let's just copy this and just paste this. Okay. And then after this, just I have no MSA, so I don't have to add this. You can add this if you want. And then for the ligand, just click on here and then ligand smiles, and then click new. So here there is option is appeared for the ligand. So for the ligand smiles, let's go into the PubChem. Just search for let's say aspirin, and here this is the smile ID. Just copy it, go to here, and just paste it, and then just run. So after a few seconds, the docking interaction will appear. Let's wait for some seconds. So here, the docking interaction is basically appeared. From here, you can zoom it, and also you can select some residues, just like this. This is basically a protein residue, and you can rotate this complex, this protein ligand complex, and this is the ligand, and this is the protein. So the ligand is basically binds with this part of the protein. Okay. And you can also see the shell, or also the Python script here, and you can further download this as a JSON file, and you can also convert this JSON file uh, into PDB file with the help of Python. Okay. Now this is a one option of using Boltz-2, and there is also another option of using Boltz-2. So as you see that Termarine Bio, and here there is protein. There is option called protein. So just copy and paste the protein sequence, and then click on the plus, then ligand. So here the one smiles ID. So just copy it and then paste this, and the structure of our ligand or drug is appeared here, and then just click on the submit. Uh, okay, you have to first log in here, basically. So just log in here, Continue. Just uh, okay. I think we have to give the protein and give the protein sequence again after login. Then click the plus option, select ligand, copy the smiles, paste the smiles, and then just submit. Okay, now here you can see that our job is running. So just wait for 1 minute. The interaction, the docking interaction will appear, I think. And let's say you, let's say this is basically here, this is basically a blind docking because we didn't specify the protein residues. Okay, so if you want to conduct a site-specific docking, then you have to, you can select specific residue of the protein. So let me show that. Just click on the reset, um, select the protein, new, uh, paste the protein sequence, and then select the ligand, new, paste the smile ID, and then for site-specific docking, and now again click here and select the pocket. Okay, pocket plus new, and select item. So uh, here you can see that there is written that define a binder. So in the docking interaction, we know that whichever one is the binder, we know that a ligand is a binder. Okay, then here the biomolecule. From here we have to select the protein. Let's say position 12. Then if you want to add another, just click on this, add, again select protein, let's say 13. Then again click on add additional contracts, then again protein, then let's say 14. Okay, so now your ligand basically tries to bind with these residues of the protein. Okay, so then just run it, and let's see. So this job is still running. So here you can see that in this case, our ligand bind with the different residue. Okay, and these residues are basically the specified residue which we have written here. So yeah, this is the way you can conduct a site-specific docking with Boltz-2. Okay, and let's just wait for some few seconds. All right, so the docking is complete. Let's view the docking interaction. Just click on the view, or you can also see the score. And this is basically a confidence score. So just click on the view, and from here you can visualize the interaction, docking interaction. And just let's just zoom this, and this is our ligand. Sorry, this is our ligand, and this is the protein. And from here you can also select the protein specific part of the protein. Okay, and yep, this is all about Boltz-2. And here you can also see the heat maps and other things. And from this turmeric bio, you can also explore many tools by just clicking on all tools like Boltz-2 or AlphaFold, etc. So thank you for watching the video. If you found this tutorial helpful, don't forget to like, share, and subscribe.